Hey guys, so in the last two videos we've talked about what reaction mechanisms are, and we saw this very interesting mechanism on how this reaction works, right? So we saw ROH plus HX giving RX plus H2O, right? And we saw how the reaction mechanism went. We tried to do a shorthand a little bit. We said, okay, H plus attacks, you get OH2 plus X minus attacks in the back, this bond shifts. We did all that stuff, right? So that's fine. Now what we're going to do is we're going to try to analyze this reaction a little qualitatively, okay? So what exactly happened here, okay? And to understand what exactly happened here, you guys need to be familiar with two terms, okay? And the terms are nucleophile, and if you know what nucleophile is, you probably know the other one, electrophile. Okay, so these are two terms which you gotta know. Any substrate or stuff can be classified into one of these two things. Okay, so a nucleophile. So basically, if I say you got phobia, right? Phobia means fear, right? Phobia means fear. Philia or phile, whatever, means the opposite of fear, right? So like or affinity, that type of a thing. So philia or phile means affinity. Okay. So what this is saying is, if I classify a substance as a nucleophile, that means it likes the nucleus. What does it mean? What do I mean when I say it likes the nucleus? I mean it likes positive charge, or an affinity for positive charge. And electrophile is the opposite, right? It has an affinity for electrons, which basically means it has affinity for negative charge, right? So that is what nucleophile and electrophile mean, okay? And we will discuss this in great detail now, because you guys got to be really sure when you're doing mechanisms as to what's going on, right? Understanding nucleophile and electrophile means you understand half a reaction, okay? Almost half. So we'll go a little more into depth here. So affinity for positive charge can also be thought, conversely as the guy has excess negative charge, right? And since everything in the world is, exchange, barter system, that type of thing, if he's going to have affinity towards the positive charge, he's probably going to have to donate some electrons, right? Bridge the gap, bridge this guy's absence of negative charges. So he probably, since he has an excess of negative charge, he can donate negative charge. And in the business, negative charge is basically an electron, right? So maybe nucleophiles are those who can donate electrons, right? Which means they have a minus sign on them, like X minus, OH minus, that type of a thing. Or you can also donate electrons if you got a lone pair. So anybody who has a lone pair or a negative charge can be considered to be a good nucleophile, right? And if you remember your 10th organic chemistry, you're gonna remember that there's something called a Lewis base, right? Or even I think this comes in 11th for you guys too. So Lewis base. Lewis base means somebody who can donate electrons, right? Because Lewis, that was his major breakthrough, right? Arrhenius just talked about acids which can dissolve water or not, and Lewis said, no, wait, that's only a small subset of chemicals, right? So he classified all chemicals as acids or bases depending on whether they can donate or accept electrons, right? Electron rich or electron deficient. BF3, the famous example, is a Lewis acid, right? Because 3 fluorines are pulling electrons away from this 4 boron, so he needs electrons, right? He is deficient of electrons, which means he will accept electrons, which makes him a Lewis acid. So typically, what we learn from this is that all nucleophiles are good or decent, at least decent Lewis bases. Good or decent Lewis bases. Okay, and you just take this and invert it. You got electrophiles. So similarly, they have affinity for negative charge, which means they have excess positive charge. So anything with say a plus on it or no lone pair can be thought of as a electrophile, right? And similarly, this means you will be a good Lewis acid. Just to link your 10th chemistry and 11th chemistry along with 12th chemistry, right? So you guys gotta understand this very carefully, okay? there are a lot more things. So let us see now what more we can talk about nucleophiles. Okay, so technically in this chapter, right, you're gonna have a lot of X minds hanging around doing stuff, right? So in this chapter, we're actually more interested in nucleophiles. Okay. Now you guys might remember that in 11th you guys had this chapter called aromaticity, right? And aromaticity had this interesting reaction that you guys learned called EAS, which stands for, if you guys remember properly, electrophilic aromatic substitution reactions, right? Just to quiz you a little bit, get you in the mood for chem. We'll say you have benzene, right? First of all, why do I need an electrophile? Why is this unnecessary? Why can I not have a nucleophile substituting on the benzene ring? The answer to that is because the point of aromaticity is that you got a lot of electrons jumping around here and there. They keep moving around. So when you're aromatic, you got electrons, induced swing current, right? Of electrons. So you're highly electron rich. So you cannot have a nucleophile coming close because there will be repulsion. Nucleophile and nucleophile, or electrophile and electrophile, can never really react much. Okay, there are exceptions. Okay, but generally they cannot react that well. Okay, so that's why we generally say nucleophile cannot attack a benzene ring, right? Why do we say aromatic? Well, that's pretty simple with the new aromatic compounds. Why do we say substitution? Because if it was not substitution, that means I'm adding across a double bond, right? And if I add across a double bond, for example, this double bond, I got something here and say, then the remaining guy becomes not aromatic. And compounds generally do not like that because aromaticity gives high stability. Okay, so that's just something for you to refresh your 11th chem. So let's get back here. So now we're going to talk about nucleophiles, right? And I remember I said that nucleophiles are anything which have a lone pair. Anything which have a lone pair or a negative charge and donate electrons, right? Donate electrons meaning maybe you can form a coordinate bond, right? You can do that. That's basically the point of donating electrons, right? So all these are properties of nucleophiles. And one more, which is that they make excellent or good or at least decent Lewis bases. Right? Now we're going to talk about the strength. How much of a good nucleophile are you, and how does that correlate with how much of a good base you are? Okay, this is paramount for you to understand nucleophiles. So if you're a really good nucleophile, right, that means you got a lot of negative charge. That means you are ready to donate electrons and form coordinate bonds as fast as possible. You got a lot of electrons, you want to put some down, right? So if you're going to do that, you're going to be a great base, right? Because you're willing to donate electrons. So let's just go over that argument again. Strong nucleophile, lots of electrons, getting ready to donate them and forming coordinate bonds. If you can do this very well, you're a good Lewis base, right? That's the order. So greater the nucleophile strength, or in other words, greater nucleophilicity, implies stronger base, right? So that's good. Now we could move on in this video itself, but let me do this. Let me stop this video for now. You guys, go over this, look at this again, and we'll do some examples, relating to this concept in the next video. And once we understand this, right, we can start diving into the SN1 and 2 mechanisms, right? SN mechanisms. S stands for substitution and N stands for nucleophilic. Okay, so we are going to be talking the whole of this chapter about nucleophilic substitution reaction. Okay, so I want you guys to go over this, brush up your ideas about what is a nucleophile, what's an electrophile. Get comfortable with this idea because I'm going to start using this very freely right now. So you guys got to be really comfortable with this. Okay, so cool. I'll see you guys in the next one. We'll do some more examples to brush your concepts up. See you guys.